Hello, everybody, and welcome to today's webcast. Today, we're going to be talking about what language models mean for your business. My name is Amanda Teschko. I'm a principal consultant at Thorogood, where I lead our machine learning and AI practice. And I'm going to be joined today by my colleague, Singh. For those of you who haven't worked with Thorogood, we're a global independent data and analytics consulting organization with offices in the US, UK, India, Singapore, and Brazil. And we really focus on helping our customers pair technology solutions with business problems across a full range of data and analytics services. We work with a number of large customers, and we tend to focus predominantly in the consumer goods, pharmaceutical, and financial services sectors. We are a technology independent consulting firm, and so we partner with many of the large cloud and technology providers and platforms. Today's webcast, we're not going to focus on any one specific technology, but you will see some demonstrations throughout in tools like Databricks and Azure. And we really look at leveraging a combination of both proprietary and open source tools. We're going to cover a couple of things today. I'm going to start by just talking a little bit about what's happening in AI and why it's happening right now, and some of the conditions that have really enabled that. Then we'll talk about large language models beyond the ChatGPT use case that I think so many of us are familiar with, before getting into different approaches you could use to take your company's data and use that with large language models to really drive greater competitive advantage. We are going to demonstrate a couple techniques for how you might do that, and we're going to look at two business cases where we're going to be creating bespoke product attribution and also generating ad copy from lengthy text descriptions of products. So to start out, let's consider what is happening in AI today. And I like to use the Google Trends slide here to track the history of the search term AI over time. We can see that something profound has obviously happened at the end of November, where that little red dot is there. There was a massive surge in the world's interest in AI, and I think many of us can probably guess what happened in that week. We know that in the last week of November, ChatGPT was released to the world, and it really got everybody talking in a way that was just more widespread than the mainstream had talked about AI in the past. Within a couple of weeks of that, we started to hear about ways that it's disrupting different industries and how much conversation was happening around it. We also started to hear by January about large sums of money being invested in the space by companies like Microsoft, who threw in an additional $10 billion into OpenAI, so the company that created ChatGPT. And we started to hear stories about the tech giants of the world really starting to clash and compete over the race to release these sorts of products. We saw this sort of AI arms race start to begin, and by February, there were more players on the market starting to release some of these large language models into the mainstream space. And so since then, we've really seen a flurry of discussion. We've seen technology vendors really running wild to try to release new features and new offerings as quickly as possible, some of which are ready, some of which aren't quite ready yet. And we've really had many of our customers trying to grapple with how they stay on pace with competitors who are adopting some of these technologies. And so we thought we would help kind of set the stage for why is this happening at the moment? What happened that made ChatGPT a possibility in November? For some time, cloud technologies have really been making storing and processing data cheaper and easier than before. And we know that we've been in this phase of digital transformation for a while now. It's created volumes of data that can be processed and analyzed. And it's really created this digital footprint that tracks everything from, our smart device usage, wearables, social media, the digitization of content, sensors on machines. It's really created all of these places that information and data can be collected and used to try to train algorithms and to learn things. We've also seen hardware advances. So graphics processing units, or GPUs, were traditionally actually used for video game development. And it's really been in the last decade, last 5 years or so, that companies have really discovered that they can apply the power of these processors to AI problems. And so the advancements in this space have really made some of the processing even more possible to do some of the large-scale training that's necessary for these models. There's also been a lot of momentum in the open source technologies and the communities around it. and they've played a really critical role in advancing AI, such as progression of neural networks, transformers, and foundation models, which are things we'll talk about in a little bit. All of these things have really set the stage for GPT to pop up in November and kind of surprise the masses. And so I think it's helpful to think about what is it about ChatGPT? How do we actually distill that down to what matters for what's happening in AI, and also make sense of that for what that might mean for different businesses? So ChatGPT is obviously an interface application that sits on top of a wider series of models, the GPT family of foundation models. But many people, when you ask them what GPT means, it's a little bit difficult for them to understand. GPT stands for Generative Pre-trained Transformer. And this is really a class of models that has made a lot of the advances we've been seeing in natural language possible. I think it's helpful just to sort of break it down for people so that we get a better sense of what these types of models actually mean and what they do. The generative aspect of GPT really refers to the ability of the model to create original, coherent, and contextually relevant text that isn't directly taken from the training data set. So for many years, for a long time, we've had the ability to train different natural language models, but this real generative aspect, the creative side, the ability to construct something that it hasn't learned on, is really what's made some of these models stand apart. The pre-training aspect is really important. So pre-training occurs on a very large, broad corpus of information. These types of foundation models are very generalizable, so they can do a number of different things and are just trained on massive amounts of data. We think about them being trained on data like books, articles, websites, other textual material. Think about all of the things in digital transformation that have digitized our information. This is giving us a place to kind of bring it all together to try to teach these general models how to do different tasks. If I were to simplify this down for large language models, though, all that pre-training is really doing is effectively trying to teach the model to predict the next word. So if I had a sentence like, the best thing about AI is its ability to, with some probability, there will be a next word after that. And what these models really try to do is get very good at predicting what that next word might be, and then giving you a response a word at a time. The transformer side of this is where we get a little bit technical, but I'll try to cover it at a pretty high level. So transformers are a new architecture for neural networks. Neural networks are a type of machine learning that has been used for some time now that really try to mimic the way the neurons in our brain work to be able to make different predictions or to understand relationships, especially nonlinear relationships in data. The thing about transformers is that they are very good at processing sequential information, like words in a sentence. And this has really helped capture some of the important relationships between words and understand context better. Transformers really only came about in 2017. So this architecture has enabled our natural language processing models to get much, much better. I think it's interesting just to do a little bit of a quick history lesson here. These language models really started back in the 50s. The Turing test was the first time we started to think about grading computer intelligence based on how well it can interact in human language. And over the decades since, we've seen an evolution of different types of approaches that are used to try to train these types of models. So rules-based approaches in the 70s and 80s, the introduction of Markov models in the 90s brought in statistical methods. And then in the 2010s, that's where neural networks really started to be applied to this space through this deep learning revolution. It wasn't until 2017 that the transformer architecture for neural networks came onto the scene through a paper that was written. And in 2018 was the first time we saw that transformer model delivered in the form of these foundation models like BERT and GPT, which is the foundation model that underpins ChatGPT. So it's just been in the last few years that we've really used transformers to scale and specialize these models so that what we're seeing today in ChatGPT is possible. Now, the important takeaway from this is that for many people, this seems like magic, but it isn't. We're predicting the next word. They're sophisticated, they're complicated, but it's not magic. There is some rhyme and reason to how words get predicted. And then for many people, it seems like it came out of nowhere, but it really hasn't. There's been a long history and evolution of this technology, and what we're seeing is the latest advances in it really bringing a lot of value to the space. Something else I think is important to touch on is that large language models are a lot more than just ChatGPT. So this question and answer interface that we think of. And I think it's useful to think of the different tasks that large language models can do so that you can think more broadly about use cases that could be applied for your specific business domain. Something that these models are very good at is text summarization. So generating concise and coherent summaries from longer pieces of text. And we've been talking to customers about doing this for processing market research documents into quick summaries. We've looked at summarizing earnings calls from competitors so that you can quickly ingest and get a sense of what's happening in the market. But there are a number of different applications for this. Question answering is one that people are probably more familiar with. So the ability to ask questions of textual data so that you can process and understand it more quickly. And we've seen examples of querying company handbooks or trying to query your structured data using natural language. Text classification is one that people don't think of that often, but that I think is really powerful. So this is the ability to assign one or more predefined labels to a piece of text. And you'll see some examples of this in the demo today, where we could take things like very lengthy product descriptions or spec sheets and try to use that information to classify it into some sort of attribute that might be useful for reporting or analysis on your data in a way that might have been difficult to do before. So taking this unstructured textual information and creating something that is more structured that can allow you to look at different lenses on your reports or the analysis that you do today. Language translation is a popular one. So being able to convert everything into a common language or into different languages. Text generation, I think, is the thing that people have been kind of most shocked by with ChatGPT, but the ability to brainstorm campaign ideas or draft email responses. And we'll see an example of this as well. And then code generation is another one. So the ability to write natural language to be converted into different coding languages. And this starts to open up the possibilities of how normal business users can start to interact with data in a way that was previously only possible by analysts or those who may have been able to talk to the computers in the language that they understand. One of the things that is important to think about, though, is these foundation models that have been created are trained on very large general information, and they perform different tasks really well, but they don't have the context of the business or the domain that you're in. What we've been talking about with customers about quite a bit lately is how do you actually use your company's data to do this? And there are kind of three main approaches that you can take here. The first approach is to just train a model from scratch. Now, this would require a broad corpus of information and a lot of processing power. Some of the foundation models like GPT and BERT, they have billions and billions of parameters. And we can think about a parameter in these models as almost being little dials or switches that we can tweak to try to adjust the answer that we get on the other side. To train these, to optimize them for the correct responses is pretty costly. It can take weeks or months, and it can cost millions of dollars to be able to do this. In that regard, we feel that this will probably be a less common approach for most companies. Some will go down this route, but most will probably take the foundation models that exist today and think about ways that they can leverage them to incorporate their own company's data. So the next approach would be to think about fine-tuning an existing LLM. So that's maybe using some of the underlying foundation models and then trying to retrain these models to update some of the parameters in that model to reflect information that's been passed in from your company. We are seeing technology vendors starting to do variations of these. For example, Google's MedPalm is a medically trained variation of the Palm 2 model. And what they've basically done is they fine-tune that model to feed in a lot of medical information so that it gets very good at answering those types of questions. And to do that, you update some of the parameters, but not all of the parameters of the foundation model. Because of that, it requires less processing power than training from scratch, but it can still be a pretty significant cost and still requires pretty deep knowledge in AI and how some of these models need to be constructed. There are also considerations here for whether you use proprietary or open source models as your base. So some AI vendors actually won't let you fine-tune their latest models. GPT-4, for example, is the latest model from OpenAI, and at the time of doing this, they won't allow fine-tuning, so changing the parameters on their most recent model. But there are some open source models where you may be able to do this more effectively. The approach that is probably the most computationally efficient and requires the least amount of data is to think about fine-tuning these models through prompt tuning. Now, a prompt is the instruction we write to a large language model that we get a response from. And when we think about prompt tuning or prompt engineering, we're thinking about providing additional context in the prompt that the models can learn from. In this scenario, the model parameters are kept frozen in the foundation model, so we're not updating any of the parameters. But when we ask the question, we're giving the model additional context so that it can answer it more appropriately for the information that we have. There are some limitations to this in that there's a limited amount of context that you can pass to these models. And we call that kind of the context window. So if I want to draw from 1,000 documents that I have in my company, for example, we might not be able to pass the text of all of those documents into the prompt. So there are a couple of different approaches that can be used to try to teach the model or fine-tune the model based on your data. A couple are few-shot learning and retrieval augmented generation. And we're going to see examples of both of those today in fairly simplistic applications. But those can get to be quite complex to give you sort of the richness of being able to bring your data into the context of what the model knows. So with that, I'll hand it over to Mani, and he's going to take you through a demonstration that shows some of those approaches.
All right, so now that we've discussed LLMs and some techniques for how they can be leveraged with your company's data, we can go into the demos that we have planned today. And there's going to be two demos. So in the first demo, we'll classify shampoo products as natural or not natural, given some lengthy product descriptions that we scraped from a retailer's website. This classification, it can be used as additional attribution by which we can group or analyze products' performance. We created a small data set with the product descriptions and a label that's going to tell us if the product is a natural product or an artificial product. And our goal is going to be to use techniques like prompt tuning and fine tuning so that the model can learn what a natural product is from the labeled examples. And in this demo, we'll be using open source models on the Databricks platform. And then for the second demo, we want to generate compelling ad copy for an Instagram image ad for a particular shampoo product. Compelling ad copies are valuable for a business since they can lead to increased conversions. And we want to generate, in terms of like audience, we'll also like go down to a specific audience. We'll do it for females aged 18 to 29. In terms of like the data that we have available for this, we have a product information sheet. So for one shampoo product, we've kind of gathered some information about it, like the product name, product description, the scent, the hair type, some health facts, and then some other information as well. And then we'll use retrieval augmented generation that Amanda touched on briefly, which is a prompt tuning technique, in order to give the model the information from the product sheet so it can use it as context. And we can get into more details about that and how it works. The model that we'll be using in this use case is going to be GPT 3.5 Turbo, which is the same model that powers ChatGPT. So now with that context, we can move on to the demo. So let's start by just taking a look at the data set that we've created. You can see here, this is a pretty small data set. Yeah, it's a pretty small data set, only 2 columns here, the product description and the category, and I'll just flip through them a little bit. But you can see these are product descriptions for various shampoo products that we have. And then there's a category label that's going to tell us if the product is natural or artificial. So this is the data set that we'll use in that first demo when we classify shampoo products. So I just want to show it to everyone here. So let's go to the demo now, into the code. So we're in the Databricks platform for this, but of course this is applicable no matter your development environment. So let's just start by loading in the data set that I just showed you, the shampoo data. And let's just split it into a training test and a test set. We're going to try a few different methods here. So we want to be able to evaluate performance across them. So we'll do that. So we'll do that on the test set. You can see here, well, it's displayed the first 5 examples of the training set. And you can see the product descriptions along with the categories. The first technique that we're going to look at, it's formally called zero-shot learning. But what this actually is when we just take a foundation model and use it as is. So there's no aspect of using company data here. We'll just take a foundation model and we'll make predictions on top of it. The specific model we're going to use in this case is BART Large MNLI. We're going to import this model from Hugging Face. And just so you understand what we mean by import, I think it's best if we talk about like model repositories and model hubs. So Hugging Face, and there are other repositories like GitHub as well. But Hugging Face is a model repository or like a model hub, and it basically just stores and hosts different models. So if I just flip to Hugging Face really quickly, this is what Hugging Face looks like. It's like I said, models are stored and hosted here, and they're easy to discover because you can search through them and like do some filtering based on tasks and things like that. So when I say like import the model, this is where it's imported from in our code. So in this case, we'll import that model. We'll specify that we're doing zero-shot classification. And in this case, like I said, no company data is involved. So we're just going to make predictions on top of this foundation model as is, and that's what we do in this next cell here when we get the predictions. You can see we calculate the accuracy, and the accuracy is at 50%. And of course, that's not very good. It's pretty much expected, like for like natural products and artificial products, like it's not a trivial task. There's like some nuance there. The product descriptions are very long. So we would expect a foundation model that has no knowledge of natural products versus artificial products. We would expect it to not perform that well. But now with that, like we can use this as our baseline. And now let's go to more complex methods where we actually give the model access to some of our company's data and we have it leverage it. So the next technique is few-shot learning. And few-shot learning is when we actually give the model a prompt as input, so that can use it as context to make predictions. So I feel like the best way to actually showcase this is to just show you the prompt. So this is a prompt that we've constructed for this example. So for the prompt itself, it's going to be instructions and examples. So the instruction here for each product description, categorize it as a natural product or an artificial product. From there, we give it each of the product descriptions along with the category that it is. You can see we do that for various products that we have. And really the goal here is now that the model has an instruction and some examples, it now has some context and it can learn to actually make classifications on its own based on these examples. And let's just go and see how this does performance-wise after we make predictions. You can see accuracy-wise, it does a bit better at 0.62, but it's still not very good. So there's still more work that can be done here. And this is when we can move on to the next method, which is fine tuning. This is where we really get more complex with things. And really when it comes to fine tuning, what makes this different is the fact that we're actually going to do some retraining on the model and update the parameters. But to begin, we're going to start the same way that we did for few-shot learning and zero-shot learning. We're going to import a foundation model. That's going to be our starting point here. And then from here, with fine tuning, like Amanda touched on, we reuse the features that were learned in a foundation model to train a new model. And really what that looks like is we unfreeze the last few layers of the foundation model and we retrain them using our domain-specific data. And this will update the weights of the parameters. And this is effectively like injecting domain context or like domain knowledge into the model. So like of your specific domain. And like, let me just show you here, like the actual training aspect of it. So you can see we initiated this trainer. We gave it our training data. We gave it our testing data as well, so it can do some evaluation on it. And we specify things like the number of iterations and like the number of epochs that we want to train for. And this specific fine tuning is called sentence transformer fine tuning. I won't go too in depth with it, but it uses contrastive learning in order to actually update the weights. So we'll retrain the model here, and you can see like this is actually going to update the weights of the model. And when we look at the accuracy now, you can see we're at 0.875, which the model is doing quite well compared to few-shot learning and zero-shot learning. So this is when we actually retrain the weights of the model. We can see a significant performance boost. And of course, with this, the data set was small. So it's like, so there's some considerations there. And also the fact that we didn't do hyperparameter tuning to the models themselves. So this is very much like a simple kind of prototyping examples, but I hope it kind of shows you the progression here where we started with zero-shot learning and we did very poorly. And as we gradually build up and like use more complex methods where we give the model access to our company's data, we can get better performance. Now with that done, let's actually move on to the second demo that we have planned. To start off that, let me just show you the product information sheet that we have available. So in this example, we want to create ad copy for a particular shampoo product. You can see the shampoo product here, Love Beauty and Planet Sulfate-Free Color Shampoo. We want to create an ad copy for this product and using the information that we have available here. Let's head over to Azure's OpenAI service. This is what we're going to use today for this example. We just want to kind of show you the different ways. The other example was like in Databricks and custom code, and now we'll actually use like an AI service to do this next part. So we're in Azure's OpenAI service, and for this example, since we want to generate text and we want to ask it in human language, we can go to the chat playground. So we can just access that here. And you can see for this chat session, this looks pretty similar to ChatGPT. We have this chat interface here. And also just note, this chatbot that you see here is based on ChatGPT 3.5 Turbo. So the same chatbot that underlies ChatGPT. The only difference here is if you look to the left side at this add your data pane, we can see that we've actually added our own data for GPT 3.5 Turbo to access. So I've done this at a time because it does take a bit of time to like upload things and set things up. But what I basically did is just upload this product information sheet to OpenAI service so that GPT 3.5 Turbo can use it to make predictions. So now that we've established that our model has access to that product information sheet, let's just try to actually have it generate ad copy. So it's the live demo, so we'll see how this goes. But we can say, can you generate ad copy for the product? And then let's just copy and paste the product name. So let's go back to the product information sheet. Let's give it the product name. And then let's just tell it the ad copy is for an Instagram image ad. And now let's just see what it will give us. So you can see it's generating an ad for us here. It's pretty long, so maybe doing some prompt engineering, we can put some constraint on how long the text is. You can see it's generated ad copy for us. I won't read through it all, but I want to point out something interesting. There's like a reference here. So if we click on that, it'll actually tell us it actually went to the shampoo. It actually went to like the spec sheet that we downloaded, that we uploaded to the model to actually get information from it. So so we can see here that GPT 3.5 Turbo, it went to the product information sheet that we uploaded, and it actually grabbed relevant information from it. So the use case for this, when you think about it, is a retailer will have like tens of thousands, maybe hundreds of thousands of products considering different variants. So considering that, it's much easier to just upload things to a vector database rather than just copying and pasting as like a prompt. You can just tell it what you want, and you can let GPT 3.5 just find the relevant information for you. Yeah, so this will wrap up the demos that we have. So let me just go back to the slides. Now that we've gone through like the demo, I'll hand it back to Amanda. She'll do some wrap up. She'll talk about some risks with like LLMs and also just some takeaways as well.
Cool. Thanks, Bonnie. Yeah, so hopefully in the demo you saw there are a number of different ways that you can implement and fine-tune these things. Selecting the model, deciding if it's a proprietary model or an open source model, thinking about the approach you want to use, the task you want to use it for. There are so many different configurations of these things. So we've just shown a couple simple examples, but we're happy to talk more about more complex situations if you have any questions. The thing that I think we should mention is that there are some cautions and some recommendations about how these things get used today and how ready they are for widespread use. I like to reference a talk by Andrej Karpathy. So Karpathy was a founding member of OpenAI, the company that was responsible for ChatGPT. And just a couple of months ago, actually back in May, he presented at the Microsoft Build conference where he laid out some of the challenges with these models, that they can be biased, that they tend to hallucinate. And so I think it's important to keep in mind some of the risks with these. His recommendations in that talk, and that we think are really sensible recommendations for thinking about how you might adopt these things in your business, are to make sure that initially, at least, we're using them in low stakes applications combined with human oversight. And that a lot of times these can be used as a source of inspiration or for suggestions, but you would want to use them more in a co-piloting type environment than as autonomous agents. I'll wrap up with just a summary and a couple of key points. So we saw a lot today in a very short amount of time. I think the important takeaways are that these large language models can really extend the possibility of what we can do with data and AI to serve valuable business goals. So thinking about new attribution, thinking about really cracking into sources that may have been hard to use before because they were unstructured or qualitative or very textually rich, and being able to process them into something that is more consumable from an insight perspective creates a lot of opportunity for companies. But the competitive advantage will be gained only by bringing your own company's data and information and context into play. And there are a lot of different ways that we can think about doing that. The technology offerings are really still evolving in this space quite a bit. We're seeing new releases and new previews every day. And there are some things that we can do today and we can do reliably today, and some things that are still evolving and taking shape. So can you recognize the full vision of this today? Maybe not, but there are many steps that you can take along the way that start to position you to be in a place to really reap the benefits of these things as they become released. That stepping stone approach is something we've been talking to a lot of our customers about what is an appropriate step to move towards this future in a way that minimizes risk and maximizes opportunity, and also positions your company to be able to take on all of the benefit of new things as they come. We've listed our contact information here. You can use the QR codes to get to our links at LinkedIn. Any questions that you might have or further conversations you want to have, feel free to reach out. We'd be happy to talk to you more about it. Thank you guys so much for joining today. We look forward to having more conversations with you as these things continue to evolve.